Hello friends, I am Shivam. Today we are going to discuss about clustering. In clustering, K-mean process. Steps of K-means algorithm. Initialize centroids. Randomly selected K initial centroids from the dataset to start the clustering process. Second, assign data points. Each data point is assigned to the nearest centroid, creating K cluster based on proximity. Update centroids. Calculate the mean position of all data points in each cluster to update the centroid position. Repeat steps. Continue the assignment and update steps until cluster stabilize with no significant changes. K-means overview. Advantage and limitations of K-mean clustering. First, simplicity. K-means is straightforward to implement and understand, making it accessible for beginner and professional alike. Efficiency. This algorithm scales with larger dataset, allowing it to handle substantial volume of a data without significant performance loss. Speed came in offer quick computation due to interactive nature, making it suitable for real-time application. Fixed number of cluster. The method requires user to specify the number of cluster beforehand, which may be difficult without prior knowledge of the data. Initial centroid sensitivity. KEM is sensitive to the initial placement of centroid, which may lead to varying outcomes if the start point are not optimal. Separilla cluster optimal. The algorithm assumes clusters are spiral and similar size, which may not reflect the true structure of complex dataset. Difficulty with density variance. K-means struggle to accurately cluster data with varying densities and size, potentially leading to misclassification. Not preparation. Preparing data for K-mean clustering. There are essential steps for optimal clustering performance. First, feature scaling. Standardize features to have zero mean and unit variance. This ensures that each feature contributes equally to the distance calculation, enhancing the clustering accuracy. Data normalization. Scale data into a specific range, typically 0 to 1, to handle features and with different units and magnitude. This step is crucial for algorithms like K-means that rely on distance metrics. Handling missing values. Address any missing data by either inputting values or removing affected record. This step is vital to maintaining the integrity of a data set and ensuring robust clustering result. Outlier detection. Identify and analyze outliers that may skew the clustering result. Outliers can lead to misleading conclusions, so it's important to address them appropriately. Fifth, importance of preparation. Through data preparation, ensure that the K-mean algorithm performs optimally, leading to accurate and meaningful clustering outcomes that can derive insights the decision. Implementing K-mean clustering in R. First, load necessary library. Utilize the dataset library to access built-in datasets for analysis. Second, load the dataset. Access the iris dataset and remove the species column for clustering analysis. Third, scale the data. Standardize the dataset to ensure each feature contributes equally to the clustering. Apply k-mean clustering. Set a seed for reprobability and execute the k-mean function with three centers. Fifth, output the clustering result. Display the result of the clustering including cluster assignment and centroids. Fifth, summary. The implementation demonstrates how to cluster the IRIS dataset into three distinct groups, yielding valuable insights. K-mean clustering. K means clustering in Python. Step 1. Load the dataset. Utilize the IRIS dataset for demonstration. Load it using data equals to load iris. This dataset include features of different iris species, serving as a great example of clustering. Step 2. Scale the data. Standardize the dataset to improve clustering performance. User scale equals to standard scale to ensure feature have a mean of 0 and a 1 variances. Apply k-mean clustering. Initiate the k-mean class and feed it to the scale data. Use k-mean equal to k-means to define the number of clusters to ensure reproducibility. Fourth one. Output the clustering result. Retrieve and display the centers of clusters and the corresponding levels for each data point. Execute print to visualize the result. Determining optimal clusters in k-mean clustering. Above methods and scheduler discover visualization. Customer segmentation. Cluster 1. Low income, high spending group, possibly indicating impulsive buyers who prioritize immediate gratification over long term saving. Second, high income, low spending group representing potential for unselling. These customers might be price sensitive or need better product awareness. Cluster 3. Balanced income and spending indicating stable and loyal customers who regularly shop and are likely to respond to loyalty program. Techniques for visualizing clustering result. Enhancing understanding through effective visualization method. Scatter plots. Visualize data points colored by cluster assignments allowing for easy identification of groupings in the dataset. Cluster centroids. Highlight centroids to show cluster centers providing insights into the average characteristics of each cluster. Pair plots display relationship between variables within cluster, helping to understand the distribution of correlation of features. Python example. Utilize Python library like matplotlib and cbum to create a scatter plot demonstrating the effectiveness of visualizing k-mean clustering result. Key takeaways from k-mean clustering presentation. Understanding k-mean. Grasp the algorithm mechanism and its interactive nature, which involves assigning data points to nearest centroid and then rescaling centroids. Data preparation. Recognize the importance of scaling feature and cleaning data to enhance the accuracy and performance of clustering result. Implementation. Apply K-mean in programming language like R and Python utilizing libraries such as skitlearn and the K-mean function in R for hands-on learning. Evaluation. Employ evaluation technique like the EBLO method and Sharpe score to identify the optimal number of cluster that best present the data. Real-world application. Leverage clustering techniques for particular applications such as customer segmentation, market research, and enhancing user experience through personalized recommendation. Love the power of clustering. Join us to explore the power world of clustering and enhance your data analysis skill through practical application in R and Python. Thanks for watching, friends.